Hello everybody, today we are going to start by reviewing how to plot points in the first quadrant of our coordinate grid. Alright, so to plot a point, you start with the y coordinate first. Is that true or false? It is false because we know that we start with the x coordinate first. Let's look again very quickly the different parts of our coordinate grid. Our horizontal line, which runs from side to side, is our x-axis. Our vertical line, which runs up and down, is our y-axis. And the place in which they meet is known as the origin. When we plot points, and the directions to get to those points are known as ordered pairs or coordinates. Remember, we are not Spider-Man. We cannot climb up the buildings, unfortunately. So we have 3 words to help us remind us how to plot a point. If you remember, we first have to go through the door. That is our origin. We then have to walk straight across the floor of our x-axis. And then we have to get on the elevator to go up our y-axis. So we have those 3 words, door, floor, and elevator, to help us remember how to plot our points. So I'm going to plot these 4 points for you. Point A is going to be in red. It's going to be at 0, 6. So I start at the door, which is my origin right here. With 0 as my x-coordinate, that means that I do not have to go to the right at all. I'm just going to go up 6 on my x-axis and plot my point. Point B is at 6, 8. That means starting at the origin again, I have to walk across the x-axis to the 6 and get on the elevator and ride it up to 8. Point C is at 10, 4, meaning again I start at the origin. I have to go all the way to the right to 10 and then get on the elevator to ride up to 4. And then finally point D is at 4, 0. That means I start at the origin again. I go to the right 4, but I do not have to go up my y-axis, at all. So that means that point D is directly on my x-axis. So look at this picture. Where could you plot a point inside of this parallelogram? There are many places that you could plot a point inside the parallelogram. So inside the black lines, not on the black lines, but inside. You have 2, 5. You have 3, 5, and 3, 6. 4, 5, and 4, 6. 5, 5, and 5, 6. 6, 5, and 6, 6. And 7, 5. So any of those points would be able to be plotted inside of our parallelogram. So now we are going to transition over into our new material, which are finding number patterns. So, story time. Miss Houchins forgot her lunch, and I can't really go out and grab anything for lunch, but I know that there's a vending machine up the hall. But I know in order to get something out of the vending machine, I have to put something into the vending machine. So I have to add something to that vending machine. And what I have to add is money, some sort of money, in order to get something out of the vending machine. So once I add that money to that vending machine, that means I'm able to get something to eat, some kind of treat, so I'm not hungry for the rest of the day. So when we're talking about our function tables or our rule tables, however you want to describe them, we can think of them as a vending machine. I have to put something in one side in order to get something out of the other. So let's look at this table. I have an X column on the right and a Y column an X column on the left and a Y column on the right. So I'm having to figure out, what do I have to do to X to get it to turn into Y? So if I'm looking at this table, I'm asking myself, self, what do you do to get the X to turn into the Y? I have to come up with a rule. My rule is always going to start with Y equals something. So Y has to equal something. So now I need to figure out how the numbers in the X column are changing to get to the Y column. There are two ways that our numbers can change. They can either increase, which means they go up, and to increase numbers in a function table, we either add or multiply. Or they could decrease. Decrease means they are going down, and in order for numbers to decrease in a function table, you either subtract or divide. So looking at my table, are my numbers from X to Y increasing or decreasing? They're decreasing. This row is going from 2 to 1, from 4 to 3, from 8 to 7, and from 16 to 15. So my rule, I have to figure out what my rule is. What am I doing to X to turn it into Y? This one is pretty simple. So remember, our rule starts with Y equals. So my rule for this table is going to be Y equals X minus 1. So that means I could plug in any of these numbers for X into my rule here, subtract 1, and I get the number that is in the Y column. So for example, Y equals 2 minus 1, and that gives me 1. Y equals 4 minus 1, so 4 minus 1 gives me 3. Y equals 8 minus 1, which gives me 7. And Y equals 16 minus 1, which gives me 15. So I know that my rule works for every single row in my table. So now I can turn these into coordinates. So I have my X column for my X coordinates and my Y column for my Y coordinates. My first coordinate is 2, 1. All I did was take them out of the table and put them into the parentheses. I then have 4, 3, 8, 7, and 16, 15. So now that I have my coordinates, I'm going to graph them. If you notice, along my x-axis, I started at 2 and counted up by 2. So 2, 4, 6, 8, all the way up. And along my y-axis, I started at 1 and also counted up by 2s. 1, 3, 5, 7, 9, and all the way up. So I'm going to plot my points. And if you remember, we start at the door, the origin. We walk across the floor and go up the elevator. So for that first point, 2, 1, I'm going to start at my origin, go over 2, up 1. For 4, 3, I'm going to start at my origin, go over to 4, and up to 3. 8, 7, go over to 8, and up to 7. And 16, 15, go all the way over to 16, and up to 15. So you can see that as I graph my points, if I were to connect my lines, it would continue constantly going up. Let's look at this problem. Antonia and Connor are playing a patterns game. Each draws a card and finds the first 5 numbers in the pattern. Then they try to find the relationship between the corresponding numbers in both patterns. So Antonia's card on the left says to start at 2 and multiply by 2. Connor's card says to start at 1 add 1/2, and then multiply by 2. So let's create a table. So I have my numbers. So this will be their first draw, second, third, fourth, and fifth draw. Then I also have a row for Antonia's numbers and a row for Connor's numbers. Because in the problem it said that Antonia starts at 2, I went ahead and put a 2 for her first draw. Connor says he starts at 1, so I put a 1 for his first draw. Antonia, let's start with her. It says to multiply by 2, or start at 2 and then multiply by 2. So 2 times 2 gives me 4. Then I have to do it again. 4 times 2 gives me 8. Again, 8 times 2 gives me 16. And one more time, 16 times 2 is 32. So now I have to start with Connor's, or finish Connor's. So with Connor, he starts at 1 and then he adds 1/2. So now he has 1.5. Then I'm going to have to multiply that by 2. Well, I'm going to think of money. So if I have $1.50, that means I have $1.50. So I'm going to put my two wholes together. So I have 1.5 plus 1.5. That's the same thing as multiplying by 2. So 1 plus 1 is 2. I then have 2 halves that create another whole. So that his second draw is going to be 3. And I have to continue the pattern. 3 plus 1/2 is 3.5. And then I have to multiply it by 2. Put the whole numbers together. 3 plus 3 is 6. And then add the 2 halves together. That gives you 7. Same thing. 7.5 times 2, or 7.5 plus 7.5. 7 plus 7 is 14. Add the 2 halves together. That gives you a whole. And that is 15. And finally, 15.5 plus 15.5, or 15.5 times 2. 15 plus 15 is 30. I take those 2 halves, put them together, and end up with 31. So now I have their numbers, Antonia and Connor's numbers, for the 5 rounds that they play. Now I need to figure out the coordinates for Antonia's numbers and Connor's numbers. I'm going to use Antonia's numbers for our X coordinate and Connor's numbers for our Y coordinate. So I'm going to start with the first draw, which will be 2, 1. I'm then going to move on to the next draw, and my coordinates are going to be 4, 3. My next draw, coordinates are 8, 7. And then my next draw is 16, 15. And then my last draw ends up being 32, 31. Now I have my numbers in my table. Now I need to know, is there a relationship between Antonia's numbers? Remember, that's the one here on the second row. And Connor's numbers on the third row. So I have 2, 1, 4, 3, 8, 7, 16, 15, and 32, 31. Do you see a relationship between those numbers? There is a relationship. I just subtract 1 from Antonia's numbers, and then I get Connor's numbers. So again, 2 minus 1 is 1, 4 minus 1 is 3, 8 minus 1 is 7, 16 minus 1 is 15, and 32 minus 1 is 31. All right, let's look at this one. It says Nora and Pavel are playing a game. The game cards show either move forward 3 or move forward 6. Just by chance, Nora draws move forward 3 on her first 3 turns. And Pavel draws move forward 6 on his first 3 turns. I need to know what number Nora will be after her first turn, her second turn, and her third turn. Well, our problem says that Nora draws move forward 3 on her first 3 turns. So if she starts here at start, she's going to draw move forward 3, which means she's going to end up at 3. She draws move forward 3 again, so she goes to 6. And at her third turn, she draws move forward 3 again and gets to 9. Let's look at Pavel. What number will Pavel be after his first turn, second turn, and third turn? Pavel draws the move forward 6 card on his first 3 turns. So his first turn, he's going to be at 6. His second turn, he moves 6 more to 12. And his third turn, he moves 6 more to 18. So each time I'm just adding 6 between Pavel's numbers. So let's use Nora's locations as our x coordinates and Pavel's locations as our y coordinates. And we're going to make the ordered pairs after each turn. So that means Nora is our x coordinate and Pavel is our y coordinate. So our first coordinate will be 3, 6, because I used the first turn. Our second coordinate will be 6, 12. And our third coordinate will be 9, 18. Now, does there appear to be a relationship between Nora's location and Pavel's location? Yes or no? There is a relationship between their locations. If we go back and look, from 3 to 6, from 6 to 12, and from 9 to 18. So Pavel is double the amount away from Nora. So Pavel's numbers are double that of Nora's.